was in college, and back in the day, we had kind of very liberal access to a machine shop, and I thought Nintendo GameCube was so cool. But what I actually thought what would be cooler would be, what if I just played the GameCube? And so I went into the machine shop. I made this computer model of this little chassis, put a bunch of gears in it, got these motors from Hobby King, and then went to the machine shop and milled out these aluminum parts, and eventually put everything together. And lo and behold, we had a remote control GameCube. So the idea here is you just shove that chassis into your formerly GameCube, and you've got a little remote control thing that you can just drive it around. And for me, this is super fun because I was like, oh my goodness, this is like a fun little project I can take to Maker Faire, I can take to anime conventions, and people will recognize it. And the little character, this little creature that I used to play with my friends, but now I can actually just play the console. So this was a fun project. And I thought to myself, well, this is all well and good, and I had a great, winter break doing this, and shared it with my 5 friends, and went to a couple Maker Fairs. But like, how do I share this actually with people? Like, how do I get people about it as excited about this as I am? And so I said, well, okay, let's look at the parts and processes that went into this, and let's make a sequel. And so that's what I did. I made GameCube Bot 2. And so I looked at the parts and processes that I did, and I said, okay, milling machines, those aren't really easy to come by in 2013 or 14 unless you've got a really fancy garage. So what if we could figure out a way to laser cut all of this instead? And so I took the design and remade all of these flat panels and reworked a lot of the process so that you could actually do this with a laser cutter. I called it GameCube Bot 2, and I said, you know what, this is cool, but I can just put the design files on the internet, but I think I need some sort of instructions. And so I said, okay, let's go to Instructables, and let's write ourselves a set of step-by-step instructions. And so that's exactly what I did, is I went and I said, okay, what's the bill of materials here? What does this consist of? What are all the parts and processes? What are the things you need? What are the files for that? And what does that actually look like to go through and step through and make every single thing? And I learned a lot from this process. A lot of it, and I'll show you in a second, but I just let this run through. And what I realized is that this is actually a lot of work. A lot of work that is done with photographs and explanations and arrows. But at the end of the day, like, you come up with something that is self-contained, and it starts with source files. It has a process that's been serialized, and so other people can, if they want to, actually go out and build this. So that's the idea behind trying to figure out a way. This is the first time I figured out how to actually compartmentalize something and just distribute it into the world that felt complete. And I said, okay, that's great. But I learned that there are some things that are kind of difficult about this process. So first off is that I am not good at taking pictures, and so it took me months to figure out learn how to take good pictures. Apart from that, the background behind these pictures can be quite messy, and I want to focus on certain parts of interest. And so that's first a process that I had to learn, is like, how do I take good pictures? And then second, like, how do I focus in and tell the builder what to focus in on these pictures? How do I show people things that are under these pictures? I have to work against gravity in some cases, and that's difficult to do with photographs. The other thing, too, is that you don't always have the best setup to do this. Lighting is hard, framing the shot is hard, and then once you've taken these pictures, they're static. They don't actually, they don't change unless if your design changes, they stay the same, and so you have to go through and piecemeal rework all of the pictures that you took. And hopefully you have the same lighting setup and all those other things. Otherwise, it's a little bit of a break. It's a little discontinuous. So this is the first time I did instructions, and I thought, this is cool, this is complete, but this is also a lot of work. And I reflected on that for a little while. And a couple of years go by, and I kind of thought to myself, well, I want to do another project. I think it'd be really fun. And I'm actually from here, and so I have this like Hollywood ethos that comes with me that I just cannot pull out of my system. And I thought animatronics were cool. I thought the film industry was cool. I thought special effects were cool. And I was like, yeah, I forgot this childhood dream of actually when I grow up, I want to do special effects. It's actually okay because CGI has replaced a lot of these things, so it's okay. But that's not to say that we can't still have fun building them. And so that was kind of the second project, is let's build an animatronic tentacle. So that's what I did. This was a summer project around 2016, and the idea behind this is that we have a CAD model again that kind of describes what this looks like in 3D. That's composed of multiple stock parts, parts you can buy, and then multiple custom parts, which are parts you can laser cut. And then finally, you put it all together. I worked from the CAD model directly to just put it all together myself. that you string it all together. That was an extra step involved in the process. And so you actually have to wire up all the tendons. And lo and behold, you have your animatronic tentacle driven by hand cables. And I thought this was super fun. And I thought, okay, but how do I share it with people? So I actually went to a bunch of maker fairs and like had people play with it, and some people really like it and some people really don't. Actually, I feel like there's a lot of interesting like social psychology that's going on, whether or not you like working with this sort of thing. And for me, that was very fascinating. But I wanted to make it easier to distribute so that other people could have these experiences of being able to have this like empowered feeling of building something that was awesome and that they could take with them. So I said, okay, let's make some instructions for this. But instead of using Instructables, I said, you know what? I'm writing for Hackaday. Maybe they'll let me write it up for Hackaday. And they did. And so I said, okay, we'll do a 3-part special. Part 1, we'll talk about what is the history of these different things and how do we get here in the film industry. Part 2, we'll talk about like the cable controller and how does that work. And finally, part 3 will be the instructions where we actually put things together. And this is the first time I said, okay, everything's driven from a CAD model. Can I use the CAD model to actually be able to make these instructions? And so I thought I was being very clever. I said, yes, I think GIFs are fun. Let's make GIFs out of everything. What I found is that, yes, GIFs are in fact fun. However, they are a little bit distracting and hard to follow. It's a little bit difficult to say, you can't pause, you can't rewind, you can't call out certain things in the middle. And now suddenly you bring in all this movie making, filmmaking steps in to kind of highlight certain things of interest. And I'm not sure that's actually the path I want to take. So what I learned, again, GIFs are kind of hard to follow. However, using that CAD model to generate some sort of instructions, that was kind of nice, because if I change the CAD model, changing the instructions again is actually a lot easier to do versus having to come up with a nice setup with good lighting, take more videos or photos. Using the CAD model is actually quite useful. So I thought about this and I said, okay, that's quite useful. Let's try to do that again at some point. So lo and behold, we moved into 2017, where SuperCon was offering a collection of workshops to people, and I said, you know what? Let's have people build tentacles. Let's see if anyone wants to build one of these tentacles. And so this time I said, well, the CAD model was useful. Can I use that CAD model to generate instructions? So that's what I did. So for this project, or for this workshop I did in 2017 and 2018, we made 15 kits. I packaged them together, and I gave them a set of step-by-step instructions, and they looked like this. So a little bit different. Now we've got various parts. They're floating in the air, which gives me a little bit more flexibility, I would say, to be able to actually show how different parts come together. And what I can do here with a little bit more granularity is kind of step you through the process in a way that is truly step-by-step, I would say. And I don't have to worry about gravity. I don't have to worry about lighting. I can just produce as many intermediate steps as I want. And the CAD model does a lot of this for you. A lot of the CAD program is helping me break a lot of this in and show what these views look like. It also will let me show you what parts consist of the particular step that we're doing. And so that's kind of what I came to SuperCon with the second year. And again, I learned a lot from this process. And so in my second try, trying to do instructions here, I actually tried to get people to build this, and I think it went quite well, but I also learned a lot about where everyone's coming from, and I realized that not everyone knows what certain kinds of screws look like, and so I can say, go get this M3 8mm long machine screw, and that means something to me, but it might not mean something to everyone else, and that was quite useful for me. Finally, I thought I was being very clever with these exploded views. I said, yeah, gravity doesn't matter anymore. I can show you whatever I want here. However, if you present that all at once to people, it ends up being it feels like too much information. It gets a little bit overwhelming to see too many steps all at once. And finally, these were black and white, no color. I thought color might be useful. It might be useful to do that sort of thing. However, people were able to build these, and I thought that was so cool, where you could come to SuperCon and you could leave with an animatronic tentacle. So I reflected on that again, and I went on to grad school. And so this is 2018 to 2022, and back in the day, I was thinking a lot about how people in research use 3D printers for not 3D printing. They use them for all sorts of mischief, to do ad hoc science or to do ad hoc experimentation. And for me, I thought, well, what if I made a platform for that? And so that's exactly what I did. I spent a year building this platform called Jubilee. It's an XYZ motion platform, and it additionally comes with a rack of tools. And those tools are to be designed by the user, in addition to having a collection of pre-made tools for you. So I had an extruder, I had a pen plotter, and then I had a syringe tool where you could extrude gels instead of filament. And the idea here is that you can build workflows in software by mixing and matching tools in different parts of the process to do different things on the bed. So the example that's being shown here is 3D printing. And so this is kind of what you can actually get when you actually do that sort of thing, is every other layer, you have a tool change, or every other layer that has different colors has a tool change, and you go back and forth and back and forth. And this, building up your model layer by layer, but now you're interleaving your colors. And what that gives you the ability to do is print these multicolor setups, or these multicolor projects, models. And that's great, but that's just 3D printing, and we've 3D printed stuff before. What else can you do with Jubilee? And so I said, okay, this is a multi-purpose thing. Let's do some lab automation. And so that's what we did. There was a battery chemistry project that we had where we needed to find the right ratio of something, and we could brute force that problem with a bunch of grad students, or we could build a machine to do it for you. And so that's exactly what we did, is we reworked Jubilee with a custom bed plate that would hold 96 well plates, which are the media that moves, lets you move things from machine to machine. That's what you do your experiments inside of. And I built a custom sonicator head. Sonicator is this stainless steel ultrasonic tip that vibrates, and it does things like break down DNA, breaks down cell walls, and it's a part of the process of what happens in a chemistry lab. One step might be go sonicate something. And so that's what, that is the flexibility of what Jubilee let you do. And I thought this is really awesome, this is cool, people can go out and do research, and they can build mostly a platform that's already done for you and add to it. And again, I thought, well, this is cool, but how do I share it with people? And I thought, okay, at this point, it's 2019, I've been doing this for a little while, I've got this. I think I know what to do. I'm gonna use instructions. But there's a problem, which is that Jubilee is actually really complicated. It's a lot of parts. So you might be able to think about this as like a Lego set, but with there's a few more, it's a bit more nuanced than that. And I thought, well, challenge accepted. I can break this down. I can turn this into instructions so that other people can put this together. And so that's exactly what I tried. And so my instructions, I broke them down into multiple sub-instructions per sub-assembly, and they looked a little bit like this, where we have different chunks that are self-contained, and they're kind of offered to people as these PDF booklets. And I thought this is a good step forward. And the nice thing about this is that you can actually do these in any order until the very end when you have to actually put everything together. And so the nice thing about this is that you can actually build this with your friends, and you can be working on different parts at the same time. Or you can do it, on your own. But at the very end is where you put everything together. And so this was a good step forward. I want to actually take you on a little bit of a journey through what these look like, because it's a little bit difficult to get a sense without actually stepping through a few of them. So let's do that right now. So let's start with just a quickie. This is one of the corner brackets. This is kind of what those sorts of instructions look like. There, again, we're using exploded views. We're calling out things by name, by number, and we're calling out what actually has to happen in that step. So that's the left side, and then you put that into this 3D printed part that you pick up. And then because it's not easy to mirror things in your head, so I don't want to say go do the right-hand side is an exercise to the user. I said why not? Let's just do the same thing. We'll just do the same thing again, because no problem. That way you don't have to do any extra thinking, any extra conversions in your head. And those are our instructions. So I want to give you one more example. Remember, Jubilee has a collection, an ecosystem of tools. This is the extruder that a lot of people use to do 3D printing. And what they'll end up doing is they'll have a rack of these, let's say like 4 of them, and you'll be able to do different colors. So let's build this from the ground up. And so I'll step you through this process. We start by putting in all these inserts into the fan shrouds. And then we put inserts into these other pieces of the base, and more inserts. And then we put O-rings onto one of these pieces, and we build the back plate. And then we go build an extruder head. This I didn't make instructions for because those already exist, because this is a product you can go buy. And then you actually tighten that in, you fasten that into the 3D printed parts. And then you go put that piece together. You make more of a unit here. Put the fan shroud on because the 3D printers will burn hot and you need to keep everything cool. Then you go install this PTFE tube into the housing. You cut it to length and you install it here. And then you put the back piece on. And then you put the fan shrouds back on, the ones that you started with. And then you actually put the fans in. And we're just about there. You're wrapping up with the actual extruder part that actually pushes the filament. And then you attach that, and you're good to go. And that's kind of the step-by-step process that I wanted people to be able to go through. And I said, okay, if you're able to go through this at a more granular level, if you can sit with things one page at a time, I think that I can get more people to build this. So I learned a lot from this process. First off, again, using the CAD model to generate instructions is very powerful because things can change and I can just re-update the instructions by sometimes it's as easy as reopening them and looking at and updating the model. Color is also useful. You can actually really call out the differences between parts when you give them colors that pop. The other thing that happened is I posted these online, I started a Discord community, and people gave me feedback. They said, hey, my experience here, this part didn't really make any sense. Can you help me, tell me what's going on here? And I took that feedback, I helped them through that problem, and I put that back into the instructions. And so the instructions actually got better. What I also realized is I actually enjoy this. This is something I'll go do at a coffee shop. Actually, a lot of this happened during COVID, and so a lot of it was done on my bed. But, now I do that at my coffee shops. The other thing, too, is that as the instructions got easier, the community grew. More people started to build this project. The other thing I discovered, too, is that this is the first project that actually had significant amounts of wiring. Wiring is still it's an unsolved problem in my head so far, but I'm working on it. So now I've shown you kind of the path that I've taken to build instructions. Let's talk about, let's give you a how-to. What are the key ingredients to actually do these sorts of things? So first off, a little disclaimer, where did I learn this? A few different places. First off, I've done this before a few times, and I learned a lot from that process. But there's other places you can go look that are related, that will give you kind of a sense of what instructions could be. First off, there's one great book, which is actually about how to design things. And this is actually a fantastic reference to it's very easy to read. It's a fantastic reference for just giving yourself some sense of common sense of how to put things together. So that's the design of everyday things. Other instructions are actually fantastic for this. When you see something that's broken down really well, I think one of the things to remember is that people who have designed the project know what they're building, but you don't. And so you're walking through this serialized process to put it together. And instructions that do this really well make that feel really seamless. So I think Lego and IKEA are good places to look. And you'll have to decide for yourself whether or not they're good examples, but I think they're great places to look and to get insight. If something was difficult for you or something worked really well, that's something to reflect on. I think practice is also going to be a great place to do this, to get better at this. Finally, the other thing that's really unrelated to this at first, or so I thought, but I actually think has a lot of carryover, is video editing classes. Surprisingly, when you're trying to tell a story and you're trying to move cuts of things together and splice that together from different video angles to say one thing that's moving continuously through time, that translates a lot over to step-by-step instructions. And finally, as a small child, I did a lot of stop motion, and that, again, can't really get any more granular than one frame at a time. So I think there's a lot of crossover from these different places, even though it's not really explicit. So finally, I'm going to get on my soapbox and give you my salty opinion here. What makes instructions good? I think if you have good step-by-step instructions, what you're doing is you're taking work off of the builder. You're thinking for them, and you're thinking about what comes before, you're thinking about what comes after. If you didn't have instructions, what the builder would start with would be a CAD model, and they'd have to spin that around in 3D, and they'd have to figure out, well, what goes together first? They have to choose an order. But instructions are great because you choose the order for them. And it turns out that if you try to just build a CAD model from any order, not all of them work, because sometimes you'll get locked out. You'll get stuck inside of places where parts don't fit anymore. So there's many orders, but there's not any order. And you can use instructions to actually serialize the process into an order that is successful for your builder. So you're creating a path for other people to go forth and build your project. The other thing, too, is that you know what your project looks like. I've mentioned this before. You know what your project looks like in the end, but they don't. And so if you can create that path for them that gives them this piecemeal, one step at a time step towards coming out with the same thing that you've done, those are good instructions. Finally, the other thing you do when you create instructions for people, you're building kind of a relationship with them on paper, where you're creating this trust relationship, where I'm giving up some of my decision making and I'm letting you decide what the next step is for me. And when the instructions are good, you can kind of yield on some level to what the instructions are telling you. If the instructions are bad, you might trash them and say, hey, I'm gonna go do my own thing. And sometimes that's a great answer, but if you have good instructions, you can carry people through successfully where they will trust you. And again, I've mentioned this before, they don't know what your project looks like, but you do. And so you have the opportunity to serialize the process here. So I think good instructions also, I have to mention this before moving into the details, is that they start with the design. There's a process here called design for assembly, where you think about when you're designing your models and how they fit together, how these different pieces fit together. You want to think about how those will fit together. You want to think about access points, when someone physically has to turn the screw to make something fit in somewhere. These are all things to consider. Finally, there's also, this is something that I didn't think about until much later, is when you have many different unique parts, it might be worth asking, like, does everything need to have a unique screw size, or can everything just be one screw? Because that makes it a lot easier to actually go through and find that one screw, because there's only the same screw. So trying to minimize unique parts, especially parts that don't get that are easily confused together, those are good things that you can do up front in your design before you make the instructions. Finally, one more thing, which is tooling. Make your tools work for you. I think so I use SolidWorks for all of these, and I think it's powerful because the CAD software will do a lot of work for me. So if you worked with KiCad before, you know that KiCad will export a bill of materials of every single part in your project. SolidWorks does the same thing. You have to give it the part numbers and you have to give it this metadata, but it will hold on to it for you. So you can right click and say export bill of materials, and then you have a list of things you can go buy from McMaster-Carr or wherever that may be. SolidWorks will also save views of models, so you can save a representation of what something looks like, and I can pull that directly into something that I would use for the instructions. SolidWorks can also do this thing that gives you the ability to explode views to show parts that are floating in space even though they're actually connected together. It gives me the ability to do this hierarchy, so I can take a piece of my project and like a sub-assembly of my project and consider that a unit where I can build instructions for just that sub-assembly. And finally, it will do CAD will update instructions or other derivatives of your CAD model when your design changes. And that's actually really, really powerful because you don't end up repeating yourself quite as often. Now, I use SolidWorks for this, but there are other good choices out there. There's a Libre, there's Fusion 360, and then of course there's this one. But again, I would say at the end of the day, like, make your tools work for you, whatever they are, even if that's just a camera. So let's talk about techniques. So here we go. So step one is your project consists of many parts. What do those look like? And that's something that you might know off the top of your head, but that's not something that everyone knows who's walking into your project. And nor is that something that you should expect them to know, unless maybe you tell them up front, hey, you gotta know what this looks like, or you gotta know, you need to have certain upfront knowledge about this project before you can build it. I think if you present them with things explicitly, there's a lot you can teach people along the way. So what I like to do with projects that are big enough is I'll make these one-to-one reference sheets where you can go print these out on an inkjet printer, and this is the petting zoo of all the different kinds of parts that you might have in your project. So the nice thing, though, is that these are one-to-one. So one of the things you can actually do is use the paper as the measurement tool. This is something that, like, it's a good thing to keep in the back of your head, where now I can describe something and you can pull it out and you can fact check yourself against a reference that is correct to make sure that you have the correct part that you're physically holding in your hand. Now, I didn't come up with this. I got this from Lego. Lego does this on their Lego Technic sets, where you can physically take one of those black beams, hold it up against the paper, and it will be the same size if you've got the right number. So this is something that gives you the ability to make words or descriptions of things salient and lets people cross-check and make sure they have the real thing in their hands before they actually put it together. Let's talk about tables. So every step of the way that people are going to build, they have a three-part process. First, what do I need? What are all the parts in this step? Second, is like a search. You have to go into your bag of parts and you have to say, okay, here is what I think I need, and here are all these parts that are going to be relevant to the step, and you gather those up. And finally, you actually look at the instructions and you actually do that assembly process of what people are, or what you have to do. So tables are a great way to call out what's here. A lot of these can be auto-generated from CAD, where you can actually tell, in this case, I'm telling SOLIDWORKS, hey, give me all of the parts that are here in this view. And I can selectively add information. I can add fields to them. I can add the quantity. I can add, or I can pull out the description from them. A lot of these are driven from metadata. And so the quantity is actually driven from what is being shown to you. So what's nice about these is that you don't have to double check the accuracy because the model software is doing that for you. So this is very powerful because there are mistakes that you just won't make because the software is helping you out. The caveat is that your model has to be CAD'd down to the nut, down to the bolt, to be able to use this to your advantage. But if you do, it's very powerful. So next off is you want to add information sequentially. You have the control of the order of operations, and you're going to take someone through that. So if we look at option B on the right, which is what I did for the tentacle, this can get a little overwhelming because you think about what has to go, what goes in first. And it's not very clear what goes in first. And so now the builder has to think about what do I do first. And there's an extra exercise here where that you can fatigue them by giving them too much work to do. And so it no longer becomes fun, it becomes work. But if you serialize the process and if you break things down granularly, they don't have to think quite as hard about what goes together in what order because the order is given to them. So this is important to keep, like if you have like a brain meter of the person who's building your thing, they only have so much patience. And there's only so much work that you should expect them to do before they will get too tired and will say, nope, not gonna do this project anymore. And so you wanna be nice to them. You wanna be kind to them, and you wanna have them take as much work away from them as you possibly can and do that for them if you can. And to go with that, I talked about breaking it up with steps. Let's break it up with sub-assemblies. You know, I can hand you 125-page manual of how to build Jubilee, and that is what it looks like if you were to look at everything at once. Or I could break things down into sub-assemblies. So I'm not the first person to do this. Lego does this for some of their bigger sets. And remember, Lego sells a toy. That's supposed to be fun, which is awesome. And so what I'm doing, you can do this here. You don't have to do what Lego does, which is put everything into the right bag for that particular kit, but you can make that process a little bit easier to work with. So here's an example. Again, we've seen this before of how I can break things down into sub-steps. Let's talk about naming things quickly. You're going to come up with a bunch of weird parts that don't exist anywhere else except inside of your project. They're going to be made from metal, they're going to be made from plastic, they're going to be made from all sorts of different processes, but you can't just go buy them off the shelf. And so you have to, someone has to go and look in that pile of parts to figure out what they're going to take out of the box. So there's a few things you can do here. You can use a naming scheme. You can put the part number or put the name of the part directly on the part, if that's possible. Or you can refer to them just with codes or with numbers, or just take away all the codes and numbers and just give them a really salient picture. And I think the instructions, when they're visual, that does a lot of that work for you. That breaks down a little bit when you have parts that are easy to confuse with each other. And so here, there are mirrored versions of these parts that are easy to confuse. And so one of the things I really want to stress is this is where part numbers actually work really well in your favor. If you can embed the number onto the part, then now it's very unambiguous as to what physical part I'm holding in my hand that's going to go into the step. And then I just put that in a table and we're good to go. So I have found that when you 3D print things, you can actually embed this on the walls, the side walls, and this works really, really well, even if your 3D printed part is very small. So color, I think, first off, I would say, if it's a stock part, maybe start with the same representative color as that real part, if you're going to use color. There's an exception to this, which is sometimes it's very confusing to see what's going on, and you can use false colors to give people a better sense of what's what. So in this case, there are two belts here. One is on top and one is on bottom, and the belt path is very different. And it's easy to confuse when you're actually kind of sewing your 3D printed chassis or belt together. And so routing these one after the other is very confusing, but using false colors makes that a little bit easier. Finally, I'm saying you should use colors, but there's also one more thing to to consider, which is not everyone can see every color. And so this actually is really cool. This is a URL that you can go hit. And the idea here is that you can pick a color scheme on the left, and then on the right, you can click through various versions of color deficiencies, and you can see what your color scheme looks like with that deficiency. And so the thing you want to do with this is you want to make sure that if your color means something and it's trying to separate two different things, you want to make sure your color scheme, that shows up as a different shade of gray or a different shade in all of these different types of color schemes. And that's where the colors work for everyone who can go through these various levels of deficiency. So this is not something that I came up with, but this is an awesome thing that I would totally recommend people go check out. And it's free, it's a web page, and thank you to the person who did this, the people who did this. Okay, so show me, it's better than tell me. So I can tell you to flip the model over and do it again. Or I can tell you to repeat this, but on the mirror end of it. But instead, because it's a CAD model, I can just do it all for you. And that way you don't have to do all this extra thinking that would be kind of somewhat burdensome to be able to have to imagine steps that I'm just telling you. So if you can take that visual step and make it visual, that's much more powerful than if you could describe those steps. That goes with actually using words sparingly. There's a lot of words on this slide, and I'm not reading all of them because I gave up reading a long time ago. So actually, if you can minimize the number of words that you're using, your reader might actually read them. And so you want to keep that thin because this is supposed to be fun. And if you give them a paragraph about why you thought this was a good idea at the time, they're not going to read it. So use them sparingly so that when they actually have to read it, it matters. The other thing you can do, this is something that's really easy to do with CAD, but you can also just take pictures and highlight what's of interest with arrows. If something's busy, then point or highlight in some way what is the important part that's going on. Because too much detail can be too much detail. And so you want to minimize the amount of detail except for the parts that actually matter. Finally, the last thing I'll mention here is to put yourself in their shoes. Imagine that you're seeing your project for the first time. This is hard to do, but other people will actually tell you when they have problems if you're open to feedback. So this is one of those cases where if this is hard to do, other people might be able to tell you for you what's easy to do and what's hard to do in your instructions. Remember, you're creating a plan, and not everyone knows all that knowledge that's in your head. So let's talk about wiring really quickly. I don't have a good answer for this, but I am going to use ideas from before. And I've seen different kind of automatic generators. I do a lot of this manually with Illustrator, and then I'll take a CAD model representation of the connector and I'll pop it into Illustrator so I can drag it around. What I want to do here is I want the model representation to look just like the actual thing you're physically holding, so you don't have to do these mental conversions in your head. You can physically hold what the cartoon is telling you to pick up. And that's because we don't all know how to do all these conversions of words to physical things because we come with different background knowledge. The benefit of doing this, though, is when I hand you a diagram after I've shown you what it's made out of, you can actually take that one-to-one representation and put it into where it's supposed to go. I call this WYSIWYG, like what you see is what you get, because that's exactly what the back of to some extent, what your wiring is going to look like. The nice thing, too, is that you only have to do this once, and then editing it is actually quite straightforward. So I want to mention this briefly, taking feedback. I think if you're open to letting people tell you about what their experience is with their projects, that can actually be very informative. So actually my rule of thumb is if more than one person had the same problem, maybe you can fix it. Maybe there's something that you can do in the instructions that make it so the next person doesn't have that problem. It's usually not their fault. Remember, it's basically never their fault because they're stepping through this process. They want to get to the result. They don't want in an unambiguous way. So you can have the ability to serve them in that way, where you can change the design such that they don't have the problem that they're having. Now, feedback, I think the easy way is the way that is actually the least convenient for the designer, which is random people talking about it on Discord. But what I like to do is I will link to the Discord conversation and dump it into GitHub. So I'll just paste. I'll say, this was the problem, paste. And that way I can always go back to it. And I can catalog things on GitHub that will get lost on Discord. That makes it easier. So if you don't know how to use Git or GitHub or anything like that, you don't have to. I'm not expecting you to, because if you told me something that was useful, at least I can go back and remember it in a way that's very easy to do this. Caveat on taking feedback. I would say feedback is somebody's experience that they're communicating to you about building something. You're the best judge for that. Someone might tell you like their opinion about your project, and maybe that's not it's not helpful for you. So you get to decide what's helpful and what's not. So what happens when you do this, when you make instructions? And what happens is that these duplicates show up in the wild. People will build your thing, and you'll start a community with this where people can actually talk to each other about their experiences. They'll talk to you about their experiences, and they'll go off and use your tool because that's what they wanted to do from the get-go, is use the thing that they came here to build. The other thing, too, is when you put CAD models of things online, they might actually show up on AliExpress, which is what happens. Your license decides if you're OK with this. But what I've found for some assembly-required projects, this actually promotes kind of a tinkering culture, where I start with pieces of your project that came from random places, and I build my own version of it. This is very different from getting a PCB clone, where it's the whole thing, where your expectations, where you're coming in with expectations that you're starting with parts rather than starting with the whole thing. This is very weird and interesting, but it's a fun topic to think about in the future. Community, people will help each other. People will share different ideas with each other. They will tell you what their griefs were, what their joys were. And if you have a place to capture that, this is the Discord for Jubilee, that's a place where other people can hang out and share and feel like there's community and a way to participate in the project. So I'll wrap things up. Hopefully at this point, like, if I want to drive home that like instructions are actually really cool. Like, documenting things can actually be really fun. And when somebody actually steps through your project and goes through that like long or painful process that you've serialized, you actually like that feels really good when somebody builds your thing. And I think instructions themselves can be very beautiful. Like, I would get that on a shirt. Yeah. Instructions are powerful. Like, you can do a lot with instructions where people will be able to talk to each other. They'll be able to convene on page 5 of this one subassembly step, and they can help each other without you. That's, I think, the other part about this that's really important, is that people can communicate with each other with a common set of information. And that's kind of that takes us to the end, I would say. So as we wind down, I hope that you consider maybe unfolding things a little more step by step. I want to say thank you to everyone who's here, to the people who helped me along the way, and to people who I actually have lost along the way, who had a say in a lot of what happened in my journey making these instructions. But with that, I'll say thanks a bunch.